Let's learn about the word problem schemas for addition and subtraction. There are three word problem schemas that we will talk about today: total, difference, change. With total problems, we have parts that are put together for a total. A typical total story is Emily saw 4 cardinals and 5 blue jays. How many birds did Emily see? But these other two stories are also total stories. Emily saw 9 birds. If 4 of the birds were cardinals, how many were blue jays? Or Emily saw 9 birds. If 5 of the birds were blue jays, how many were cardinals? In each of these total stories, there are three consistent things: a part, and a total. It doesn't matter if the story is asking about the total, or some of these stories may be asking about one of the parts. To help students determine whether a word problem is a total problem, they should ask themselves, are parts put together for a total? And once they decide that the word problem is a total problem, they can use a total equation: P1 plus P2 equals T, part 1 plus part 2 equals the total, or a graphic organizer such as you see here. Here is an example of a worked total problem. The student decided that this was a total problem. We are putting the sugar cookies and the chocolate chip cookies together. So they wrote a total equation. They filled in the information below the total equation, and then they solved for the unknown amount. Here, it was an unknown total. The unknown total was 62 cookies. This is an example of a total problem with a missing part. And in this total problem, there are more than 2 parts. In fact, this total problem has 4 parts, one of which is missing. Starting in grade 3 and moving through the middle school grades, most total problems don't just have 2 parts put together for a total, but 3 or more parts put together for a total. The next schema we'll talk about is the difference schema. Here we have greater and lesser amounts that are compared for a difference. The classic difference problem is Sinead has 9 apples, Amanda has 4. How many more apples does Sinead have, or how many fewer apples does Amanda have? This question could also ask, what is the difference between Sinead and Amanda's apples? But these other two difference stories are also difference problems. In the second story, Sinead has 5 more apples than Amanda. If Amanda has 4, how many does Sinead have? In the third story, Amanda has 5 fewer apples than Sinead. If Sinead has 9 apples, how many apples does Amanda have? In all of these stories, there are three consistent things related to the difference problem: a greater amount, a lesser amount, and a comparison for the difference. So to help students determine whether a word problem is a difference problem, they can ask themselves, are amounts compared for a difference? And once they decide that it is a difference problem, they might want to use the difference equation: G minus L equals D, greater amount minus a lesser amount equals the difference, or some different types of graphic organizers such as you see here. Here is an example of a worked difference problem. Here, the student decided that they were comparing two amounts, the wooden beads to the glass beads. So they drew a difference graphic organizer, filled in the information from the word problem, and solved for the unknown. In this case, the unknown is the difference, and the difference is 67 more wooden beads. The next schema we'll talk about is the change schema. In the change schema, we have an amount that increases or decreases. So on the left-hand side, you can see examples of change problems where we have an increase. So Shanna had $4, then she earned $3 for cleaning her room. How much money does Shanna have now? And you could read the next two stories and you can see that the second story, the change is missing, and in the third story, the start amount is missing. On the right-hand side, we see change problems with a decrease. Reese baked 9 cookies, then she ate 3 of the cookies. How many cookies does Reese have now? In the second story, the change amount is missing. And in the third story, the beginning or start amount is missing. In all of these stories, there are 3 consistent things: a start amount, and something happens to either increase or decrease that amount, that's called the change. And that change then contributes to an end amount. To help students decide whether a word problem is a change problem, they can ask themselves, does an amount increase or decrease? And once they decide a change problem is a change problem, they could use the change equation ST plus for increase minus for decrease, C equals E. So that's the start plus or minus the change equals the end. Or they could use different types of graphic organizers as you see here. Here is an example of a solved change problem. In this change problem, we're talking about a plant, and that plant grows across several months. So here we used a change diagram. The plant started at 3 3/4 inches high, and then it grew or increased, and it ended up at 9 1/8 inches tall. So our job is to figure out the change. Here we show the change with a question mark. So the change is 5 3/8 inches. And here is an example of a change problem with multiple changes. Many change problems starting in third grade and continuing into middle school have maybe two increases, two decreases, or perhaps an increase and a decrease. This example here has a decrease, then an increase. So first she spent some money and then she saved some money, and our job is to figure out the new end amount after we spent and saved some money. So that is an overview of the word problem schemas where addition or subtraction are involved. We talked about total problems where parts are put together for a total, difference problems where greater and lesser amounts are compared for a difference, and we also talked about change problems where one amount increases or decreases. So thanks so much for tuning in. If you want to learn more, my name is Sarah Powell. Reach out to me on Twitter, find me at my website, or email me.